Welcome to the DIY Honda Garage channel. The DTC P0101 specifically indicates a problem with the mass airflow MAF sensor circuit in Honda Civic models from 2006 to 2011. This diagnostic trouble code signifies that the MAF sensor is not performing within the designated range or performance limits set by the manufacturer. The MAF sensor plays a crucial role in measuring the amount of air entering the engine, thereby allowing the engine control module, ECM, to calculate the right amount of fuel for optimal combustion. When the readings from this sensor fall outside acceptable thresholds, it can lead to various engine performance issues, including reduced power and increased emissions. This slide provides a foundational understanding of DTC P0101, setting the stage for deeper troubleshooting steps and diagnostics related to potentially faulty components throughout the vehicle's air intake system. The mass airflow MAF sensor is strategically located in the intake duct of the Honda Civic, just after the air filter and before the throttle body. Its primary role is to measure the volume and density of air entering the engine, providing essential data to the engine control module, ECM, for adjusting the fuel-to-air mixture. The ECM uses this data to optimize engine performance and efficiency. An overview of other affected components includes the PCV hose, intake air duct, air cleaner, purge control solenoid PCS line, brake booster, and the brake booster hose, all of which are integral to the vehicle's air intake system. Any issues with these components can contribute to MAF sensor performance problems. Understanding their precise locations and functions is crucial for diagnosing the DTC accurately. Several possible causes can trigger the DTC P0101. One of the most common issues is poor electrical connections, which can prevent the MAF sensor from receiving accurate readings, leading to confusion in the engine's performance metrics. Additionally, any damage to components such as the intake air duct or vacuum hoses can disrupt the airflow measurements, further complicating the sensor's function. A dirty air cleaner element can also hinder airflow, affecting the MAF sensor's ability to measure air density accurately. These root causes must be thoroughly investigated before proceeding with advanced diagnostics, as resolving these issues can sometimes immediately rectify the DTC without further troubleshooting. When DTC P0101 is present, various symptoms may manifest, affecting both engine performance and vehicle behavior. Reduced engine power is one of the most noticeable symptoms, with drivers experiencing sluggish acceleration and an overall lack of responsiveness when pressing the gas pedal. Rough idling can also occur, where the engine appears to struggle to maintain a steady RPM when stationary, leading to an unpleasant driving experience. Additionally, an increase in emissions may be observed, as the incorrect air-to-fuel ratio can lead to an inefficient combustion process, subsequently causing more noticeable exhaust emissions. Awareness of these symptoms is critical for drivers to identify potential issues promptly, thereby preventing further damage or performance degradation. The first step in troubleshooting DTC P0101 involves a thorough inspection for poor electrical connections and any visible damage to several crucial components. Start by examining the positive crankcase ventilation PCV hose, the intake air duct, and the air cleaner for signs of wear or cracks. Failing to address these areas can lead to incorrect readings from the MAF sensor, thus triggering the DTC. Additionally, inspect the purge control solenoid PCS line, brake booster, and brake booster hose, as problems here can also lead to performance issues. If all inspected parts are in good condition, proceed to the next step in the diagnostics. If any part shows signs of damage, it must be repaired or replaced before continuing. The second troubleshooting step requires a focused inspection on the condition of the intake air duct, particularly in its connection to the air cleaner. Check for both damage and looseness. A loose intake air duct can cause unmeasured air to bypass the MAF sensor, resulting in miscalculations by the Engine Control Module, ECM. Tight connections are vital to ensuring that all airflow is correctly measured, and any issues found must be rectified immediately. If the intake duct is damaged, it will need to be replaced. Upon confirming that the duct is in good condition, continue with further diagnostic steps to isolate the issue effectively. In the third troubleshooting step, focus on inspecting the air cleaner element. Over time, the air cleaner can become clogged with dirt and debris, significantly impeding airflow into the engine. A dirty air cleaner can lead to inadequate air measurements by the MAF sensor, causing performance issues reflected in DTC P0101. Check for visible dirt accumulation. If found, the air cleaner element should be replaced to restore optimal airflow. After replacing the air cleaner, you'll improve engine performance and ensure accurate reading by the MAF sensor, enabling the ECM to function as intended. If the element is clean, you can advance to the next step in the troubleshooting process. A fourth troubleshooting step involves preparing for a focused check of the MAF sensor under controlled conditions using the Honda Diagnostic System, HDS. Begin by turning the ignition switch to the lock position, ensuring that all electronic systems are completely powered off. Next, quickly turn the ignition switch to the on position, 2, which will power up the vehicle's electrical system and allow access to data readings without starting the engine. This preparatory step is crucial for isolating the MAF sensor's performance measurements before proceeding further, which will allow for a clearer diagnosis of the underlying issue related to DTC P0101. In this fifth troubleshooting step, utilize the Honda Diagnostic System, HDS, to check the readings from the MAF sensor. Look specifically for values close to 0.2 grams per second, or around 0.5 volts, which indicate proper sensor performance. These readings are critical to determine if the MAF sensor is functioning correctly. If the readings match the expected values, proceed to the next step, as this confirms that the sensor circuit is likely operational. If the readings diverge from these specified thresholds, further investigation into the sensor itself may be warranted, leading you to engage in more targeted diagnostics or repairs. After confirming the initial readings from the MAF sensor, the sixth step involves starting the engine. Once the engine is running, vary the engine speed between 2,000 and 3,000 RPMs actively. This step is necessary to observe how the MAF sensor reacts to changes in airflow as the engine speed fluctuates. While you're doing this, continuously monitor the MAF sensor readings through the Honda Diagnostic System, HDS. A functional MAF sensor should display changing values corresponding to the adjustments in engine speed. If these readings do not change, this may indicate a malfunctioning MAF sensor or other issues in the system that require further investigation. At this point, continue the troubleshooting by holding the engine speed at precisely 3,000 RPM without load, meaning the vehicle should be in park or neutral. This controlled situation allows for a consistent assessment of the MAF sensor's performance at elevated RPMs. Monitor closely until the radiator fan activates. The fan should engage as the engine temperature rises, which is a normal operational characteristic. After observing the fan's operation, allow the engine to return to idle. This step ensures that the engine can operate efficiently across different RPMs, which is critical for confirming that the MAF sensor maintains proper performance under various conditions. The 8th step involves taking the vehicle on a test drive to assess real-world performance and analyze recorded freeze data parameters. During this test drive, maintain a focus on specific factors, including engine speed, vehicle speed sensor readings, manifold absolute pressure, MAP sensor values, and MAF sensor data. These are critical for confirming the health of the air intake system. By operating within the parameters previously recorded during diagnostic checks, drivers can ascertain if conditions have improved or if the DTC P0101 is still present. This real-world testing is essential to verify that all components perform effectively after any repairs performed, ensuring the vehicle operates optimally under typical driving conditions. As we conclude the troubleshooting process for DTC P0101, it's essential to verify that all repairs performed successfully addressed the issue at hand. Begin by confirming that all diagnostic trouble codes have been cleared from the vehicle's onboard computer, as this resets the system and can provide a fresh start for performance evaluation. Next, it's advised to run the vehicle under various driving conditions to ensure that all system components are functioning as they should. Recheck the MAF sensor and monitor performance metrics to confirm improvements. This final verification step is crucial to ensure that your repairs were effective and can help prevent any recurrence of the P0101 code. Preventive maintenance is essential to avoid the recurrence of DTC P0101 and to ensure your Honda Civic operates at peak performance. A periodic inspection of the MAF sensor and its components can help maintain accurate airflow readings. Cleaning the MAF sensor regularly, as per manufacturer recommendations, helps remove dirt and debris that accumulate over time, which can interfere with its functionality. Additionally, changing the air cleaner element at regular intervals will prevent airflow restrictions, contributing to efficient engine performance. Regular inspections of related intake components are equally important, as early detection of wear can help avert more significant issues in the future. Proactive maintenance can lead to prolonged vehicle life and better fuel economy. In conclusion, addressing DTC P0101 for the 2006 to 2011 Honda Civic necessitates a thorough understanding of the MAF sensor's role within the vehicle's air intake system. This diagnostic trouble code can stem from a variety of issues, including poor connections, damaged components, or dirty filters. Effective troubleshooting encompasses a series of structured steps to pinpoint the exact cause and involves vigilant monitoring of the MAF sensor's behavior under different operating conditions. By adhering to preventive maintenance practices, such as regular cleaning and timely replacement of filters and components, you can minimize the chances of the issue recurring. Recognizing the significance of these factors ensures the optimal performance and longevity of your Honda Civic. Please like and subscribe to the channel. See you next time.